Hello everyone, welcome back to the channel. I'm out here with the A10. I'm gonna get a flight in today. This won't be a maiden, I've already flown it. I've only got maybe 7 or 8 flights on it. Last time I brought it out to fly, I had a aileron servo go out on me in the air. Luckily I got it back down on the ground, so I had to order a new servo from Motion RC, and the servo came in last night, so I got it in. I was off today, so I figured I'd come out and get some flights on it. Do a little bit more dialing in on the gyro and on some of the setups and features in Inav. So I got it out here. I'm the only one at the field. Nice morning. The winds are pretty calm. It's going to stay calm most of the day. And it's coming right down the runway, maybe a little bit of a crosswind. But I've learned with the A10, it's very resilient to high winds. It flies very, very good. And this probably will be the calmest day that I've had it out. Last couple times I flew it, it was pretty windy. Over my setup, all the things that I use when I come out here and I prepare all my planes for flight, like my charging setup. I'll go over that a little bit, how I store everything, and then kind of give you guys footage and some details on how I set up the A10. So here's my setup for charging. I got this case here from Harbor Freight, and I put a couple of computer server power supplies inside. Each server is putting out 12 volts on each one of those XT60 ports, but I have an XT90 port right here where they're running series, giving 24 volts input into the iCharger. I'm using an iCharger DX12. It does pretty good. I can usually charge my 6S 5,000, 6,000 packs. Looks like it took them about 15 minutes on this battery, and then on the other battery took about 20 minutes. So it's a pretty quick charge. I can charge 2 at a time. The batteries I'm running now are SMC 6000s, and I'll also be flying with the SMC HV 6700s, as well as the 5900s here. So I'll be flying with those on the A10 today. I usually bring out an airspeed meter so I can keep track with the wind speed, and I usually keep a log of that so I know how the plane will perform in different wind speed environments. And I have this little weather vane. It kind of helps me to see which direction the wind is coming. Cause I got the computer out today because I will be doing some tuning and adjustments in Inav. One of the things that I know I need to sort out is I was flying and maybe I was going about 80 or 90 miles an hour, and I cut the throttle immediately in a dive, and I got some oscillations. So the reason why is the way I have the gyro set up in the pit setup on the A10. I run a high gyro gain at low throttle, so that at low speeds I have a lot more authority over the surfaces, or the gyro has a lot more authority over the surfaces. But then at high speeds, when the throttle is at full throttle, it'll kind of bring that gyro gain down. Well, the problem with that is that there are situations where I can be at a high speed but then low throttle, and therefore I'm getting overcompensation because, you know, the gyro is like, okay, well, you're low on the throttle now, so let me up the gains, but the plane is still traveling pretty fast. So one of the things I'm going to do is I'm going to create a logic command where the gyro is going to switch between different pit controllers based on the airspeed from the pitot tube here. So what I can do is I can have it set up higher, so if the plane is like, say, 40 miles an hour or less, it'll have one set of gyro gains, and then, you know, somewhere in the middle, say 40 to like 70 can be another set, and then 70 on up can be another set, and it'll automatically switch back and forth based on airspeed rather than throttle position. So I'm gonna give that a shot today. I kind of figured out how to do it at home on the bench, and first I'm gonna just get a flight in as it is now, and then I'll come back and I'll start playing with that. But yeah, this is the A10. I have brakes on it, which I don't have on any of my other models. I'm running brakes because I don't have reverse thrust. And I wanted to make sure I had a way to stop the plane if I come in hot, and the brakes seem to work really good. We also have, I'll kind of go over the setup inside. Some of it you guys probably won't be able to see because all electronics are deep down in there, but right there is the receiver. That's the Express LRS receiver, which works phenomenally. And then I have, you guys got to excuse that we're not far from a racetrack and you can hear the cars running. So that is the Hall effect current meter right there, and back in the deep down in there, it's hard to see. Let's see if it focuses. The flight controller is on the left, and then behind that is the original board from Freewing that all the servos run through for the mixing and everything, and the landing gear sequencing. This A10 is set up almost exactly like the F-16 as far as like parts and how everything is connected. The same as the F-16 and the F-22. The only difference is that because it's a dual battery setup with dual ESCs, I'm only doing current meter on one of the batteries, and that's the battery that's also running all the flight systems. So the other battery, you know, it's just, I know that if I get low on one battery, I'll probably have a little bit more capacity in the other one just because it's not tied to the flight systems. I didn't really know of a way that I can get dual battery, you know, telemetry with Inav. You know, there might be a way. If you guys know, let me know in the comments below, but that's just how I got it set up for right now. Let's pop the canopy on. You guys can see how the canopy looks. All right, so canopy's on. So I got it looking semi-scale on the inside. It's not exact, it's just kind of some stuff that I came up with to make it look like a cockpit and have the LCD display and the arm sight in there. I kind of positioned everything to give me as much view out of the front, so I didn't want that dash, if you would call it that, to be sitting up really high or really far back. I tried to kind of shrink it down a little bit to just give myself a more better visuals coming out of those front side glasses. I did polish the canopy as best I could. I spent a lot of time polishing it. It's, you know, it's not crystal clear, kind of like the F-16, but it's very clear. I can see really well out of it. I also made these mirrors here. I 3D printed some mirrors, and then I got a piece of mirror plexi, acrylic, and I just used a laser cutter to cut that out and glued it to the 3D printed pieces, and they came out really well. And I even have them on like it's not really a hinge, but it's I have to glue it in place, but I have it where I can position and adjust them to kind of get the angle I want. So I have it set up now to where if I look out at either the left or right mirror, I can see the motor, the cell on the back. And the main reason why that was kind of important for me is because it's a twin. Once I put my goggles on and I taxi out there, unless I take my goggles off and look at it, I may only have one motor spinning. And so I want to be able to make sure that I can see that both engines or EDFs are spinning, so I can just look in the mirror real quick and, you know, make sure that they're powered up and working. That way I don't make a mistake and take off with just one engine driving. So that's pretty much it. I got the antenna here for the DJI O3 air unit that it's running. Underneath the canopy, I'm running the same cooling duct that I did on the F-22 and F-16, which works great. I have no overheating issues. And then we have the LCD display from FPV Toys in there. So yeah, so this is it. I'm going to go ahead and put the battery in here in a second, and this will be, I'm not sure exactly what number flight it is, but it's gonna be like 8 or 9 or something like that. And I'll take it up and I'll talk to you guys while I'm up in the air. Let's get it going.